Alright guys, welcome back to this channel, and if you are new to this channel, this is BAM's Tutors Academy, where we solve mathematics related questions. And in this video I'm going to be solving, we want to determine the convergence of this sequence basically using epsilon definition. So the basic definition for epsilon definition is just that for all epsilon greater than 0 there is n bar epsilon in n such that the absolute value of xn minus l is less than epsilon, meaning that we just want to do the formula absolute value of n minus l less than epsilon, and we will get an expression that n is the subset of the formula greater than an expression that has epsilon. That's what we want to do. But now we don't even know the limit of this sequence. We are not given. We just want to discuss it. So now, first of all, we need to go and look for the limit of this. So what is the limit of this expression? So I will let's find the limits to infinity, because it's an infinite sequence. So the limit of n to n plus the root of n plus 1 is very simple. So since the degree of denominator and numerator is the same, I'll just divide by the degree. So I'll just say n over n over 2n over n plus the root of n plus 1 over n, right? So definitely this gives me 1, this gives me 2, plus, now this is the same thing as writing the root of n plus 1 over the root of n squared. You know, it's the same thing as square root of n squared, is the same thing as n. So, and with the knowledge of sort, this is equal to 1 over 2 plus the root of n plus 1 over n squared. Do you get that? So this should give me 1 over 2 plus the root of 1 over n plus 1 over n squared. So if I should put the limits, I would have something like 1 over 2 plus the root of 1 over infinity plus 1 over infinity. And 1 over infinity is 0, so that means everything here is 0. So I'm basically left with 1 over 2. So this is my L. That's my limit. So now let's now work with the proof to show that this is actually convergent. So we know that the limit is 1 over 2. So let's just write it somewhere. So the limit L is equals to 1 over 2. So going by the definition, for all epsilon greater than 0, there is n by epsilon in n such that the absolute value of n, which is n over 2n plus the root of n plus 1 minus L, which is 1 over 2, absolute value is less than what? Is less than that epsilon. So what I want to show is that I want to establish the fact that when n is standing alone, it will be greater than n by epsilon. So let's find the LCM. So the value of the LCM is 2 into 2n plus root of n plus 1, right? This is less than epsilon. So this in this, I'll have 2n minus the whole of this, that is 2n plus the root of n plus 1, right? So opening the bracket, I should have something like 2n minus 2n minus the root of n plus 1 over 4n plus 2 the root of n plus 1 is less than epsilon. So obviously 2n cancels 2n. So I'm left with the absolute value of minus the root of n plus 1 over 4n plus 2 root n plus 1. This is actually equals to the positive because it's redefined, right? It is having an absolute value. So I can have the root of n plus 1 over 4n plus the root of n plus 1. Now I can actually remove an addition from the denominator, so it is less. So this is actually less than root of 4n plus 1, sorry, root of n plus 1, I mean root of n plus 1 over 4n. This is less than that. So if that is less, and this is actually less than epsilon. So I can now work with making it happen. So what will I do to make this work? uh okay, so what if I take the square of both sides? So if I should take the square of both sides, I would have n+1 over 16n squared, right? Is less than epsilon squared. Okay, that makes sense. So let's clear up this part. So in that case, I can continue by saying n+1 basically is less than 16n squared epsilon squared, right? So what if we just say that 0 is less than 16n squared epsilon squared minus n minus 1? Is that good? So that will be 16n squared epsilon squared minus n minus 1 is greater than 0. Is that good? So we are working with greater sign, and we can now apply the knowledge of our quadratic formula. So minus b, let me write it somewhere. So if it was x that's our variable, it will have been x is equals to minus b plus or minus square root of b squared minus 4ac over what? Over 2a. But here we are working with n. So basically my n is our x. So n is equals to, my b in this case is a minus 1. So minus into a minus 1 plus or minus the square root of b squared, that is minus 1 squared minus 4 times a. My a is 16 epsilon squared over 2a. Okay, this is times minus 1 also because of c. So 2 times a, that's 16 epsilon squared. Okay, so from there we can know what is happening. So we'll now have n is equals to 1 plus or minus the square root of 1. That minus here and the minus here will be plus. So plus 16 times 4 should be 64 epsilon squared over 32 epsilon squared. So now this is greater because we're working with greater than 0. So n is greater than 1 plus minus 1 plus 64 epsilon squared over 32 epsilon squared, right? So ladies and gentlemen, we have been able to show that n is greater or equals to n bar epsilon, because the whole of this one here is our n by epsilon, because there is a function of epsilon and this is the n. So we have been able to show that this sequence, it converges. So if you have not subscribed to this channel, do that immediately before you come to the end of this video. All right, so I will see you in the next video, but before then, make sure you keep studying, make sure you keep solving analysis, because that is the beauty of mathematics.